Welcome to Mac 2311 for Engineers, exam number 4, problem number 8. In this question, they go ahead and they say an engineer determines that a force acting on an object is represented by the following Riemann sum for small values delta x as x varies from 0 to 1. Evaluate the limit of the Riemann sum by first rewriting it as a definite integral. So if we know that, we know that if you take the limit of this Riemann sum, that's the same as going ahead and just finding the integral. And doing an integral is a whole lot easier than doing a Riemann sum. So if we could just go ahead and somehow translate this into a definite integral, we're in good shape. So, well, we know it's just going to be integral of some bounds, and they actually give you the bounds. They tell you it's from 0 to 1. So that's fine. And then you're going to have a little dx here. But what's the actual function we're trying to integrate? Well, if we read this, you could just ignore the summation symbol. So all that we have left is 10xi star 1 minus square root of xi star times delta x. Well, this delta x is kind of like that dx, so you can also not worry about that either. And wherever you see these xi stars, they're just simple x's. So your function, you could go ahead and say, was 10x times 1 minus square root of x. So going ahead and doing the whole limit as, n goes to infinity of this, Riemann sum here, you could do it the long way, but that's the same thing as just going ahead and solving this little integral. We just had to look at this Riemann sum and pick out the f of x function, and then this was it. So how do we solve this? Well, we can run that 10x through it, and you get 10x minus 10 to the x to the 3 halves. You get a dx there. And then if you integrate this, you can see this is going to come up by a power, so it's going to become x squared, and you divide by 2, so that makes it a 5 here. Then minus, and this you increase by a power, so that's going to be x to the 5 halves. If you divide by 5 halves, that's the same thing as multiplying by 2/5. 10 divided by 5 is 2, 2 times 2 is 4, so this just becomes a 4. And the dx goes away, so you're just going to be evaluating from 0 to 1. When you plug 1 in, you just get 5 minus 4, and when you plug 0 in, it all just goes to 0. So 5 minus 4 minus 0 just gives you a 1. And that's going to be answer choice A. That's all there is.